Yeah, good afternoon, everyone. Can anybody confirm whether my voice is audible or not?
Yes,
Yes,
sir.
sir.
Yeah, thank you. So once again, I welcome all the participants to this online faculty development program on cloud and fog computing platform for Internet of Things application. So we have 4 hours per day, starting from today up to 8th March. So we have prepared the program schedule in such a manner that it will cover both theoretical aspect, also the hands-on perspective, and also the applications of cloud, fog, and IoT in various engineering applications. So I have already said the program schedule. If you look into the program schedule from tomorrow onwards, uh, 4 days we will see only the hands-on. So I have said what are the requirements, and whenever I'll get a requirement from any resource persons, I'll share with you. Try to make your system ready with that software or installations, so that you can also do the hands-on. And I'll try to also share all the materials, those who are given by various research persons. I cannot commit all the materials, but whatever research materials will be received by research persons, I will forward to you so that you can refer after the end of this FDP also. So let us start the first session. So in this session, I am going to tell you about the basics of cloud computing. In fact, this technology was started in the year of 2008, and we have almost 16 years in this particular technology. And this particular technology is very, very popular in comparison to other information and communication technology based technologies. Behind every technology nowadays, in the background, we have cloud computing. So we need to understand what are the basics of cloud computing and the predecessors of the cloud computing. It is not a complete new technology. It is depends on other associated technology which was developed prior to the cloud computing. That also I'll briefly discuss in this particular session. So the main agenda of this particular talk, which I have mentioned here, will start with a very simple graph, or you can say cycle, which is repeatedly released by one of the popular research and development firm called as Gartner. So we'll see the hype cycle of our cloud computing as released by Gartner, and also we'll see the popularity of cloud computing in Google Trends. Once we have got some idea related to why we go for this particular technology and what are the emerging area in the field of cloud computing, then I'll tell you about what is the importance of the computing. Computing is not a new word. Computing was there since, you can say, before 50 and 60 years. We do calculation initially, then we go for computation. So why there are different technologies, why there are different computing paradigms are coming day by day, need to understand. So I'll tell you some of the informal examples in motivation so that you will see what is the importance of each and every computing and why there is a requirement of a new computing paradigm. Like we talk about in this FDP related to fog, which was coined by Cisco in the year of 2016. So there are so many other technologies are also coming into market. Like you can see, there is another term computing I am going to tell you in this FDP, that is called as osmotic computing. Fog started in the year of 2012, but osmotic started in the year of 2016. And nowadays also people are looking for other computing paradigm, just like quantum computing and other computing paradigms. That's why we need to understand what is the main importance behind computing and computing paradigms. So we'll see the background of cloud in trends of computing. Especially, we are going to see what is parallel computing, what is distributed computing, what is cluster computing, what is grid computing, utility computing, and finally the cloud computing. So these are the various trends through the entire process has gone through. So we'll discuss one by one technology so that you can differentiate one technology from any other technology. So these are the topics that we are going to discuss. Then I'll tell you formally what is a cloud computing architecture. So we know every technology has a architecture, like we have a very popular architecture for computer system. We call that as a John von Neumann architecture. Similarly, cloud computing has also a architecture so that you will know uh, what are the components of this architecture, how these components actually interact with each other. Then we'll discuss about a simple concept of virtualization, although we have special sessions related to the virtualization. But cloud computing is popular because of this virtualization technology. And there are several types of virtualization we have. So we'll discuss the concept of virtualization. Then I'll summarize the lecture. So coming to the hype cycle for cloud computing, which was released in the year of 2023. It was released actually in the month of July 2023. You can see in this hype cycle. So Gartner, who actually released this cycle, it is a popular R&D firm, and Gartner released this cycle twice in a year, probably in the month of January and July. So why this hype cycle is important? That is more you need to understand why. What is the main purpose of going for this hype cycle? This hype cycle is not only for academia, but it is also for the industry. So if a technology is new into the market, then you can find that technology in this Gartner cycle. What is the expectation of this of a particular technology? That also you can find in hype cycle. Hype cycle is not released only in the field of cloud computing. You can also search for hype cycle in artificial intelligence, machine learning, quantum computing, information communication technology. There are several hype cycle released by uh, Google, our Gartner, in each twice in a year. So every time you can see a technology is here and there in this particular hype cycle. And if you closely observe this particular hype cycle, you can see in the x-axis we have time and y-axis we have expectation. So it says that over a period of time, what we can expect from a particular technology. Like every human being is having a life period, okay, starting from birth to death. So we go through various phases. Similarly, every technology also passes through 5 different phases. You can see these phases. First phase is called as innovation trigger. Innovation trigger means a technology, whenever it launched new to the market, it is present in the innovation trigger. Because most of the people, they are not aware of this particular technology, and you can say adaptation of this particular technology is also very low. Because if you go to a particular company by saying that you adopt this particular technology, they will think in various angle because the technology is not mature. So in innovation trigger, there are a lot of difficulties for a particular technology. Over a period of time, it goes to the peak phase, it goes to the disillusionment phase, it goes to the slope phase, and finally the technology is obsolete. So the technology is not that much emerging after a period of time. Like nowadays we are using smartphone. If I talk about a small handset without internet connectivity, now you can see nobody is using that. So it has already reached the plateau of its productivity. Nobody is now willing to use that system, that was you can say mobile phone, without internet connectivity or without having applications. So every technology will passes through these phases. It may happen that in a particular phase, a technology stay for 2 years, another technology may stay for 5 years or 10 years, and so on. So, as per Gartner, Gartner never released this cycle as a open source. So like if you see the January 2024 was over, but you will not able to find the latest hype cycle, or getting the latest hype cycle you have to pay. So in this hype cycle, you can see several technologies are mentioned, and they are also mentioned with some color. Like you can see some technologies are mentioned with white color dot, right? White color dot indicates that the technology's plateau will be reached within 2 years. So you can see in the caption or legend, it is written that if a white color dot is there, the technology will there in the market for another 2 years. After that, obviously nobody is going to use that particular technology because it is completely matured, or nobody, or you can say that a new technology which is replacing that particular technology. Similarly, you can see some technologies in the duration of 2 to 5 years. For example, if I go for hybrid cloud computing term, as per the Gartner, it says that its plateau will be reached in 2 to 5 years. Similarly, if you go for the black color dots, here you can see there is a technology called inter-cloud data management or cloud portability. These technologies are sustained in the market for up to 10 years. And also we see a yellow color triangle here, which says that this technology will sustain in the market for more than 10 years. So this is an expectation. This is not the reality. As per Gartner, Gartner conducts surveys and takes opinion of various chief technical officers, and they summarize it. So as per the current hype cycle, quantum computing as a service, which is you can say merging of quantum computing and cloud computing. So that will sustain in the market for 10 years. So the reason of showing this particular hype cycle is that when we start our career in a particular technology, we should look into the Gartner hype cycle. If a technology which is mature and there is no scope for improvement, obviously nobody is going to use that particular technology. But if a technology is expected or expected to reach its peak, let's say in 3 to 5 years, or sustain in the market for 10 years, so if we can contribute by research or development, or you can say by adding some kind of features to that particular technology, definitely the technology is going to be accepted by the community. And we can also see that our products, if I develop any product in that particular technology, that will be used by multiple users or in the industry also. So this is the Gartner hype cycle. So always my advice is to go for the Gartner hype cycle before adapting any technology or any company perspective. Now coming to another important interesting fact, like if we go for Google trend. So whenever a new technology is coming to the market, so if we are not aware of that particular technology, then we go to Google and search for that particular technology. Not only that, when you assign a particular work to a student, the student usually search about that particular technology in Google. So if you go to Google Trends to know the popularity of a particular keyword, so simply you can type in Google Trend and click the link. And once you enter to the Google Trend page, you can write a particular technology name. For example, you can see here I have written the technology name is cloud computing. And you can also restrict your search, or you can open your search based on different regions. Like here you can see I have selected worldwide. I want to know the popularity of the keyword cloud computing in all over the world. You can restrict to our country or continent or a particular location. Also, Google Trend provides you a feature that in what is the period in which you want to know about the searching of this particular keyword. So the maximum period that is given by Google Trend is 2004 to present. So you can restrict to a particular year also. For example, if you want to know from 2023 only, so that also you can do. You can also select various category, a particular technology with respect to entertainment, with respect to art, with respect to various things. So if you do say search related to the cloud computing, you can see from 2004 to 2021, you can see more or less it is getting close to 50 out of 100. But its peak is achieved during this particular period. I think this period is around 2012 or 2013, you can say. So what it indicates, the suppose we got 100 million search query related to cloud computing. So we restrict that 100 million search query, or we normalize the 100 million search query out of 100. Every particular keyword, we are not, this 100 does not mean that it is showing 100 million search query or 100 billion search query. It index everything or normalize everything with the index value of 100. And you can see in the current status in 2024, up to 2024, it is above 50. So still people are interested in the field of cloud computing, although you can see 2015 to 2021 period, the number of search queries is less. But due to adoption of various other technologies like quantum computing, artificial intelligence, machine learning, blockchain, again, cloud computing is day by day emerging. Similarly, you can search for hybrid cloud computing. You can also write another technology here to compare cloud computing with any other computing paradigm. Not only that, Google Trends also provides you highlights about what are the which country the maximum search query is generated. For example, you can see here, these are the 5 countries where maximum search uh, queries are received by Google. Starting from Zimbabwe got 100. I told you everything is scaled from 100. So Zimbabwe is in the first position. Ethiopia is in the second position with index value of 98. And our country, India, is in the third position with the index value of 92. Similarly, Nepal is in the fourth position, having search query of index of 73, followed by Kenya. And if you want to know the index value of any other country apart from these 5 countries, then you have to click your cursor in the respective country's location, so you will get the details about that particular country and its index value. Not only that, Google Trends also focuses on what are the topics and what are the queries people usually pose in the platform, Google platform. Like you can see, some of the related topics related to cloud computing is computing, storage, data, GCP, which is Google Cloud Platform, and service. So these are the related topics of our cloud computing. Similarly, what are the different queries people pose in the Google? So they are interested to ask what is cloud, what is cloud computing, or the cloud, or cloud service, or what is also coming as a search query. So not only this list, you will get a complete list. If you go to Google Trends, you will find more than 5 search queries or more than 5 research topics related to the cloud computing. Now, if you restrict your search to India, previous statistics I am showing you with respect to worldwide, but here I have restricted it to India. So you can see the number of search query is again peaked during that period only. That is 2011 to 13, you can say. And gradually it is decreasing during 2014 to 2021. And now it is slightly increasing. You can say the index value is close to 25, not more than 50 like we have seen in the worldwide. But you can see in our country case, it is close to 25. Because if you search the keyword hybrid cloud computing, we may get a better statistics than the cloud computing term. Similarly, if you want to know which state you are getting more search query, you can see here Andhra Pradesh is the first position having index value of 100, followed by Tamil Nadu, followed by Puducherry, followed by Karnataka and Telangana. Okay, again, if any state name is not mentioned here, if you put a cursor in that particular location, you will get the corresponding. associated with cloud computing, and they have also life period of more than 10 years. Like quantum computing as a service has a life period of 10 years, or you can say intra-cloud data management is having a life period of 5 to 10 years, and you can say, let's say, cloud optimized hardware or multi-cloud management, they are having a life period of 2 to 5 years. So these technologies are mm, uh, other technologies associated with cloud. They can stay in the market for more than 10 years. Similarly, Google search queries also, you can see repeatedly the search queries are increasing day by day. Or 15, we are getting an index of 50 means it is sufficient to say that people are now also interested in this particular technology. Now coming to some of the motivational example in which I am trying to address why computing is important. For example, if you go for a banking system, or you can take an example of our education system. Suppose a faculty member or a bank cashier or a software professional is given with a computer system, and that person uses the computer system for 7 hours per day. Only 7 hours in the overall the working hours, except the lunch time, except the other breaks. Suppose you are using a computer system for only 7 hours. And let us assume that there are 6 working days. So you can say 7 into 6. So total number of hours we use a computer system is 42 hours. Again, in these 42 hours, your system may be idle, or you are writing a code, or you are watching a movie, or you can do anything with your computer system. So I'm only calculating whether the system is switch on or switch off. So if every day we are using our system for 7 hours, then every week we are using our computer system for 42 hours. But if I ask you what is the how many hours are there in a particular month or a particular period of time or a particular week, then you will say in a week we have 24 into 7 hours. So we are using 7 cross 6, 7 hours per day for 6 working days. But total number of hours per week, if we calculate, it is 24 into 7. If you calculate per month, you multiply number of days. So if you calculate this one, you will get 42 divided by 168. 42 divided by 168. So it is 0.25. It indicates that only 25% of the time you are using your system, but rest point of time you are not at all using your computer system. So what it indicates, our resource utilization is very poor. If some resource is with you and you are utilizing it for 25%, so definitely 75% of the time you are not using, but you are paying for the rest 75%, because the time in which you are not using your system, for that also you have paid, because it is the dedicated system for you. So the question arises, why we will pay if we are not utilizing a particular system? If I am using a system for 100% of time, then I will pay. If I am using for 25% of time, I am going to pay only 25% of the cost, not the 100% of the cost. So that emerges why computing is important, or it also indicates that how to improve the resource utilization of a computer system. Like if you write a program in which your computer system is busy for, let's say, or utilization reaches to 80%, definitely you are utilizing it properly. Not even if it is not 100%, if it is close to 100% or 80%, 90%, then you can say obviously the resource utilization is better. But if the resource utilization is 25% or 10% or 5%, obviously it is not a good resource utilization. So we need some kind of computing paradigm in which the cost need to be reduced, cost need to be minimized. At the same time, resource utilization also need to be maximized. Similarly, if you go for the study given by IBM, or if you go for the study by NRDC, which is also done a lot of surveys in cloud computing. So you will see, as per the report by National Resource Defense Council, NRDC, so they mentioned that average utilization rate of our personal computer is only 5 to 10%. Imagine the situation, you can say before COVID, or after the third phase of COVID. So we know how we are attending the lectures offline. We are taking lectures or attending various programs offline. Very few amount of FDPs are conducted online. So obviously, if you are attending a lecture online, you are utilizing your system. But if you are attending offline, at the time your system is in switch off mode. So if you consider average utilization rate of all the personal computers, it is hardly 5 to 10%. And you know, server is more powerful than a personal computer system. Normally in a computer lab, we have let's say 30 to 50 computer systems, and these systems are connected to a server. So server utilization is also, you can see, 30 to 35%. So server case it is 30 to 35%. Per personal computer case it is only 5 to 10%. So it indicates that the resource utilization is also not reached 50%. Although you can say this study was conducted in the year of 2000, but many reports also suggested that this case is also true even today. So the major important part is how to improve the resource utilization. So how to minimize the cost, how to provide the resources as a part of services that will help us to improve the resource utilization. Now, another informal example I can tell you, like if you observe a newspaper delivery boy, a newspaper delivery boy gives newspaper to the subscribed customer. For example, in a month of 31 days, newspaper is, let's say, delivered only for 25 days. Out of 31 days, the person is delivered for only 25 days. So you are going to pay only for the 25 days. You are not going to pay for 31 days. Because rest 6 days, you have not received the newspaper or the service is not given to you. So you are not going to pay for the service. But you are not looking into whether the newspaper reached to a particular state or not, or particular location or not, or whether the traffic of our city is normal or abnormal, or there is a terrific traffic. That we are not looking into. Simply we are calculating how many days the newspaper is delivered to us. Based upon that, we are going to pay for it. Similarly, whenever we are traveling from one city to another city, you may be aware of a site that is called as Comsum, or we are habituated with IRCTC. So IRCTC also now providing food, and Comsum is also providing food. So for example, if you are traveling from let's say Hyderabad to Bhubaneswar, so by train, let's say one intermediate station is, let's say, Visakhapatnam. So you have given your PNR, your mobile number. Through PNR, they can extract your birth number, train number, coach number, and other details. And you have booked a meal in Visakhapatnam railway station. Suppose your train is delayed by 2 hours. So if your train is delayed by 2 hours, so the vendor that is Comsum, they will track your train, and they will come to know that yes, after 2 hours only this train is going to reach to this particular station. So they will deliver the food at that particular time when it reaches to a particular station. So if they are not going to deliver, definitely you will ask for a refund if you have paid the amount, or if you have pre-booked, you are not going to pay for it, right? If you have already given that it is, let's say, cash on delivery kind of thing, so you are not going to pay for it. So what I try to convince with these examples is that if a service is provided to the customer, then the customer is going to pay for that particular service. Otherwise, we are not going to pay for that particular service. And based on our usage, we are going to pay for it. Now, if you take an example of Google services, day by day, we are very much habituated with various services provided by Google. Like we are using Google Email, Gmail, or we are using Google Map, we are using Google Photos, we are using Google Lens. But if I ask you, can you locate where your emails are stored, who is owning them, who is maintaining them? So you don't have any answer for it. In which location it is stored, whether it is stored the geographical boundary of our country, or it is stored outside our country, that we don't know. That means service server location is not known. For example, if you go for Amazon, Amazon has two data center in our country. One is at Mumbai, another is at Hyderabad. So whether our emails, for example, I am using some Amazon services, whether that service is given from Mumbai server or outside country, that I also don't know, right? Until unless you have asked or you have restricted your location, it may be assigned from any location. So we don't actually care. Simply what we want, we have given with a username which is public, password which is private to us. So with this username and password, if you are given a terminal or any device that is connected to internet, then through that you can able to browse your emails. Right? You go to any location, you go to abroad or you go to any state, any location. If you have a system with internet connection, so through which you can browse your internet through your username and password. So the only constraint which we are looking in this case, that is internet. If internet is there, our job is done. And we need a device which is internet compatible. There are many devices are there. They are not directly able to connect to internet. But if a device is there with the internet facility, we are able to get all the things from our Google account. So if you see, one of the chief scientists of ARPANET in 1969, his name is Professor Leonard Klenikrop. He mentioned that after 50 years, 1969 he mentioned, after 50 years means it is 2009, sorry, 2019. Okay, if you take 1970 plus 50, it is 2020. So he mentioned after 50 years, you will see computer is just also like an utility, like other systems. For example, if you see our electric connection, right? We have a meter. So in winter season we are getting less amount, but in summer season we are getting more amount, right? So based on our usage, we are going to pay, right? If you are using more electricity, then you have to pay more. If you are not using electricity, or if you are out of station for 1 month, then you are not going to pay for it. So it is just like an utility. Early days electric is an utility. If you remember, we have hand phones, right? Our let's say uh, the old telephones, right, which is connected through wires. So every month we are getting bills, whether it is a prepaid connection or postpaid connection. Based on that, we are getting bills, and we have to pay for it, right? So based on how much you need, it is going to charge some amount to you. So like electric is an utility and telephone is an utility. So there are many other utilities are there. So the scientist mentioned that after 50 years, people will see that computer is also treated as a utility. That is true, because if you go to Amazon, if you go to Google, you can host your website, you can host your application without owning a computer system. I don't need any internet. I don't need any physical computer system to own a server. Simply, I can request Google or Amazon or any cloud service provider who will help us to provide the service. And I am going to pay for it. Maybe I am using it for 1 year or I am using for 5 years. So based upon my our requirement, we are going to pay for it. So soon after this prediction, you can see in 2009, Professor Rajkumar Bhuiya, he wrote a very nice article by mentioning that the computing is the fifth utility after water, which is one of the essential utility. Nowadays also, you know, waters are also given with units, right? There is a meter connected to the water pump. So based on your usage, you have to pay for it. Electricity is also an utility. Gas connection, nowadays piped gas is also coming. So that is also based on your usage. If you use more, then definitely you are going to pay more. And telephone is also one of the utility. So after these four utility, water, electricity, gas, and telephony, computing becomes the fifth utility of the system. Now, why we need this cloud system? Why not the traditional systems are sufficient? Like in our computer lab also, we have sufficient number of computer systems, right? We have 50 computer system, 100 systems. Why we want to go for cloud? Why we need a virtual infrastructure rather than the physical infrastructure? For example, if you see one of the popular site, that is top 500 site, you can browse in Google. Top 500 list, 500 site. The site name is top500.org. If you visit this site, you will get the details of the fastest supercomputer. And we know supercomputers are more powerful, right? So always there is a, you can say whether supercomputer facilities are provided by cloud provider or not. So you can see the top 500 list. This list is also updated twice, like our Gartner hype cycle. So I have taken the top 500 list for last year, that is November 2023 list. So these are the 5 fastest supercomputer in our world. For example, you can see the first in the list is called as Frontier. The configuration of this also supercomputer you can also find. So this supercomputer Frontier belongs to United States. And if you see the number of cores in this supercomputer is 86,99,904. So it is around 87 lakhs, I can say. So see here, if you go for our computer system, we have i3 processors or we have i5 processors and so on. And number of cores is either 4 or the number of processors cores are 8. And you see the power of a supercomputer. The supercomputer is having around 87 lakhs of cores. So why these supercomputers were developed? Because there are many scientific engineering applications are there in which you can say we need a lot of computational power, we need a lot of storage power. So that can be provided from the supercomputer, right? But supercomputer is situated in a particular place. So if anything is situated in a particular place, if any natural calamity happen or any kind of failure happen, then the whole network is going to be collapsed. Like NIT Warangal is also having association with IIT BHU to use our Param Sivaya supercomputer. The supercomputer name of IIT BHU is Param Sivaya. So we have given access to use IIT BHU Param Sivaya computer. So you can see in the top 5 list, our country's supercomputer is not there. And you may be aware that Param is the fastest supercomputer in our country. So placing everything into a centralized setup is not a good solution because it may lead to a single point of failure. So what do we want? We want computational power in a distributed system, not in a centralized system. But you can also see here that how much petaflops of you can say instructions, like we calculate a million instructions per second, how much instructions you can process through the supercomputer, that is mentioned here. This is the RMX and this is the RPeak. Obviously, RPeak is greater than the RMX. And you can see what is the amount of power required to run a data center, or you can say in this case it is a server. Cloud case we talk about a data center, but supercomputer case we talk about a supercomputer, we talk about a centralized location where we need this much power to run the particular supercomputer. So obviously resource management is more important. The resource is not managed properly and you require a very high amount of power consumption, then also it is not a good solution. Similarly, you can see in the top 500 list, another supercomputer is there, also belongs to United States. Another supercomputer also United States. Then Japan is in the 4th position and Finland is in the 5th position. So the idea of showing this list is that these are only centralized system, but we want a distributed system which may help us to do the computation. And for every technology, the background is our computing. So, yeah. So if you go for ACM computing curricula 2005, they mentioned computing as a goal-oriented activity. So for example, starting from our a simple calculation. Suppose we are doing 2 plus 3. It is a simple calculation. So suppose you have written a program, and that program takes a lot of inputs, and you want to process through a computer system. So you want to do computation. So your goal is to, let's say, finding the addition of a certain number. So this is a goal-oriented activity. So ACM mentioned that the computing is any means, you can say, it should be a goal-oriented activity. It may require some designing and building of a hardware or software system. Like you can see that a range of systems are there. One system, a workstation is more powerful than the personal computer. Supercomputer is more powerful than the workstations. Or servers are more powerful than the workstations. So we need to design and build a hardware system as well as the software system. We cannot enhance hardware without software, or we cannot release a you can say a well designed features software without any hardware. So in computing also includes you have to process something, you have to structure something, you have to manage various kind of informations. Suppose I'll give you a data set, and if I want to ask do processing this particular data set and tell me some meaningful results. Data analytics, you can say. These are also needs computing. Or if you do scientific studies or engineering applications, one of the example I can tell you, that is weather forecasting or any government funded projects which are helpful to our general public, they all are hosted in some cloud based system, or you can say computing based system. Similarly, we want to computing also include making computer system to behave intelligently. Over a various computing paradigm, day by day, our intelligence is increasing. Like early days, people are habituated with cloud computing. Nowadays, we come with fog computing. We come up with osmotic computing, and we come up now with the quantum computing. So day by day, we want to improve the intelligence of the our computing system. Also, computing required for creating using communication and entertainment media. Like if you talk about YouTube, YouTube stores a large number of videos, and video qualities are also varies, right, based on the different users. So in order to maintain such system also, we need computation, storage, and other things. So we cannot define computing with respect to a generalized term, but with respect to applications, we can say what is the meaning of the computing paradigm. So actually the list is complete, the list is virtually endless. You can see various kind of computing in our day-to-day life. It is not restricted to a simple program or simple application. Now coming to our next point of discussion, what are the trends in computing? Behind the cloud computing, there are other computing paradigms are also there. So briefly, I'll tell you what are the computing paradigms behind the cloud computing, or you can say cloud computing is a successor of these technologies, or these are the predecessors of cloud computing. So we have parallel and distributed computing. We'll see details about this one. Then we have grid computing, followed by cluster computing, utility computing. So based on the advantages and features of these four computing paradigm, cloud computing was developed in the year of 2008. So let us discuss one by one computing paradigm so that you have a overall idea that how cloud computing is different from other computing paradigms. Okay, you can find the similarity and differences with these technologies. Now, if you look into distributed computing, prior to distributed computing, everything is centralized. Like I told you, supercomputer, it is placed in a particular location. We are using the supercomputer of IIT BHU. It is placed in the campus of IIT BHU. So it is completely a centralized computing. So early computings are more or less said to be centralized computing. You may consider your computer system. It is also centralized computing. It is a dedicated system. You are not sharing your things with others. So it is located in a particular location. Or if you are using a laptop, wherever you are going, you are using that particular system. So it is not connected to any other system. So you can see in an example here, there is a mainframe computer here, which is connected to several terminals. So I can say also that these terminals are requesting resources from the mainframe computer. So let's say this particular terminal is making a request to the mainframe computer. seeking some kind of resources, and this mainframe computer is providing resources to this terminal, right? Like in our computer lab also, we have installed some operating system, and it is connected to several computer systems. So when you switch on a computer system, one copy of that operating system is loaded in a computer system. Similarly, other terminals are also requesting different kind of resources. They are not asking the same kind of resources, different kind of resources to the mainframe computer. So uniprocessor computings are used here, so they can be considered as a centralized computing. So the problem with centralized computing, as I already mentioned, if this main computer is failed due to some reason, it may be a power failure, it may be a hardware failure, or it may be a natural calamity in a broad level, I can say. So these terminals will not get service, okay, because they are dependent on this mainframe computer. So in order to avoid this one, we have distributed computing. You can see in the distributed computing, now all these computers are not dependent on each other. So here the relationship, you can say this one is treated as a master, and these are called as your slaves. But there is no master-slave relationship in the distributed computing. Each and every computer is independent. For example, if you see this particular workstation is failed, then it is not impacting these two workstations. But if they together collaboratively do some work, definitely it is going to impact the performance. For example, I'll say a simple example. Suppose I want to add 1 plus 2 plus 3 up to, let's say, 100. Okay. So what I did, I divided this task into 3 parts. I can say T1 is the task 1, T2 is the task 2, T3 is the task 3. So I have assigned these workstations to compute 1 to 33. I have asked this computer system to calculate 34 to, let's say, 66. And I have asked these workstations to calculate the remaining part, that is 67 to, let's say, 100. Okay. So if a computer system is failed, if a workstation is failed in the distributed computing, definitely this computation is going to be impacted. Okay. But other computer systems, suppose T2, T3 can manage this one. One of them can take initiative, or they can further divide this task into 2 parts. One part can be solved by this workstation. Another part can be solved by this particular workstations. So there is no single point of failure in the case of distributed computing. But in the case of centralized computing, it is prone to the single point of failure. Now, if you see the definition of distributed computing, you can see this definition in various angles. Like it is a field of computing science that studies the distributed system. We talk about distributed system in which we want to achieve distributed computing. So it uses of a distributed systems to solve various computational problems. If you want to solve a very complex problem in which you need a large computation, single computer is not sufficient, or you can say group of computer systems are also not sufficient, then in that case you have to go for distributed computing. One of the popular project I can say you, that is called as BOINC, which is a very popular platform that is called as Berkeley Open Infrastructure for Network Computing. So this platform is under University of Berkeley. So under this platform, they are running various projects, real life projects. One of the real life project is our weather forecasting. Another project you can see under which is running under this platform is called as SCTI at home, which says that search for extraterrestrial intelligence at home. So these projects do not own any number of computer systems. They don't have any fixed infrastructure. Rather than anybody can participate in this particular platform. So you can go for BOINC platform web page and download BOINC software. Okay, there is a executable file. Once it is successfully installed in your, this platform is successfully installed in your computer system, then you can add as many number of projects on this particular platform. Once you add this platform, whenever your system is idle, they will use your processor cycles to execute their application. So in that way, this platform is running, and it is seen that more than you can say millions of computer systems or millions of users are giving their processor cycles to run various real life applications. And you can see once you install this platform and add a particular project, if you observe your processor utilization, it is more than 90%. So it is not possible for a single system to do it, but if we donate or if we participate or if we can provide our resources to other, then together we have a very massive amount of computational power that we can do it. So for solving various computational problem, we use actually distributed computing. So you can see here, every processor is having its own memory. Like here I am giving an example of 4 processors. These 4 processors are connected to each other, or these 4 systems, you can say, they are connected to each other. They may not be located in the same place. You can say they may be located in different country or different continent, and they are having a local memory. And they exchange the information through message passing interface, which we call as MPI. Okay. So any task is assigned, so that can be distributed over these processors, so that together they can achieve a particular task. So as per Wikipedia, distributed system are several autonomous computational entities. Each of them is having the local memory. This is called as a local memory. And they communicated through the message passing interface. But if you look into the operating system concept, the processors are actually communicating with each other through various communication lines, or they can communicate through the high-speed buses. We have high-speed buses in our system. So through that, they can exchange the things. And each processor is having its local memory. Okay, they can do their local task also, and they can participate into a collaborative task also. For example, the users who is owner of this company, they can execute the task, and at the same time, it can also execute any collaborative task which is given by the distributed system. So some of the real life examples of the distributed systems, you can say internet. In internet, the servers are not located in a single place. Rather than these servers are distributed over the whole world. But most of these servers are residing in United States. So if we put everything into same server, again single point of failure can come into the picture. So we can put a server in Singapore, we can put a server in Japan, another server in our country. So if we distributively put this thing, so if a particular server is not giving response, then it can be redirected to other server. That's why internet is a true distributed system. Similarly, ATM we are using in our day-to-day life. So that is also an example of a distributed system. So once you make a transactions, the same copy of the transaction is also propagated to other systems. For example, now you can also have more, you can say, more number of cards for the same account. Account may be given with more than one debit card. So if 2 persons are using the debit card and they are residing in different cities, so immediately whenever you are drawing any amount, that is immediately reflected to other cities ATM also. So it is just like created as a distributed system, and the synchronization is also done in a very faster rate, so that there should not be any kind of double spending or any kind of mismatch in the account balance. Similarly, if you look at our intranet, in every organization we have intranet or work groups, we share our information. That is also considered as a distributed system. Similarly, what are the things in a distributed system or components in a distributed system? A server can participate in a distributed system. A workstation can participate, laptop, desktop, personal digital assistant. So any device is having a computational power or a storage power. So that can be participate in a distributed system. Some of the properties of distributed system, which is also required for cloud computing. For example, fault tolerance. As I mentioned that, let's say there are 3 computer systems. There are 3 different computer systems. They are connected each other to provide the resources, or they can together solve a particular computational task. So if a computer system is failed, then obviously it is going to impact the performance, but the entire network should not be failed. That's why fault tolerance always says that even if there is a existence of a fault, it is not going to impact you much. Obviously, there should be a minor impact, but it should not impact the whole system. And each node plays a partial role. Okay, in order to do any kind of computational task, we decompose the task into small units, and each small task is assigned to one unit, one computational systems. So every system play a partial role. No system is having full role. Together, we can say this system is having a full role, full-fledged role. But individually, the systems are having a partial role. And they may not be aware of the other things also. For example, if you do some kind of collective task, so maybe this computer system, whatever work it is doing, it is not known to other computer systems. So they share the resources. Each user is having computational power storage, so they share their resources with other user. Like I told you about BYNC. BYNC is also an example to share the resources of your computer system with the University of Berkeley. Now load sharing. So in a centralized system, a centralized manager is there. The centralized manager has the main role on receiving a particular application or producing the result for that particular application. So once the centralized manager receives certain tasks, it has to decide whether it need to give to a system, first system, or the second system, or the third system. Okay, but again, the centralized manager is failed, then the entire network is going to be collapsed. So load sharing says that whatever amount of that load you are going to give to each and every system, more or less the workload should be same. One system should not be overloaded. At the same time, another system should not be underloaded. Next, it is easy to expand also. Suppose another two systems wants to join a distributed system. It is possible. Any number of users can join. Any number of users can leave into the distributed system. Like BYNC system, as I told you, many users can join. You can join, participate today. Tomorrow you don't want to continue, you can also discontinue it. But over a period of time, it is observed that the minimum 10 lakhs plus machines are active at the same time. And these are the voluntary contributions given by each and every individual. So more or less centralized computing case, we want to achieve parallel computing. Like we talk about high performance computing in the case of a supercomputer. We have so many cores and we want to assign the task to each and every core. But in distributed computing, parallelism can still be achieved, but the location of these computers are not in a single place. That's why if we compare parallel computing with distributed computing, we can say parallel computing is a subset of our distributed computing. And parallel computing is tightly coupled in the sense that if a component is failed, it is going to impact other components. But distributed computing is a loosely coupled system in which if a computer is failed or a system is failed, it is not going to collapse the entire system. Then why we need distributed system? Because cloud is an example of a distributed system. In cloud, we have data centers. Every cloud service provider is having certain data center. Like Amazon is having 2 data centers in our country. So these data centers are actually providing the resources. Suppose you need storage, large amount of storage. Let's say 500 TB of storage, cloud can provide it. If you need, let's say 64 virtual CPUs, cloud can provide it. But purchasing 64 vCPUs or purchasing 500 TB of storage, it is not possible for an individual or a small organization, I can say. So that's why we are going for the distributed computing. So not all applications require distributed computing, but various applications you need to observe which require large computations, large storage, large network. In that case, definitely you will go for the distributed computing. So based on the performance, distributed computing, you can say the task executed by the distributed computing can be categorized in compute intensive task or it may be data intensive task. Okay, you may need computation or you may need data. For example, suppose I want to compute the value of pi. And for that, let me use Monte Carlo simulation, one of the very popular simulation in mathematics, in which we set a range for each and every input. Suppose you are taking x is a input and y is input, you have to specify its range. Okay, and you have to run this simulation periodically or based on different kind of data. Okay, so in this case, you need a lot of computation. So obviously, the computation of pi is considered as a compute-intensive task. It is not a data-oriented task. But if you look about our social media platforms like Facebook, we are using in our day-to-day life, or in grid computing, one of the popular one is called as LSC, that is Large Hadron Collider. So these platforms actually require large amount of storage. They have large amount of file. Day by day, it is increasing. So in that case, we call that task as a data intensive task. So data intensive task, it requires more or less it is a computation, and more or less it is a storage, data storage. Then you can do also computation. Once you store your data periodically, you can do some kind of computation or you can analyze on that particular data. But overall, it is called as a data intensive task, but computation of pi is said to be a compute intensive task. Distributed computing is also used for its robustness. So there is no single point of failure, and other nodes can execute the same task if a particular node is failed. If a node is failed, its task can be given to any other node. Suppose a new node is joining in your network, you can execute in that network, that computer system also, because every computer system is having a partial role. That's why distributed computing is popular. Now coming to several applications. So there are several applications in which we need a set of processes that are distributed across a network of machines, and we want to work together to solve that as a common problem. Although we have several systems in our distributed system, but we treat our entire system as a single system. Okay, for example, as a user, if you want to execute a particular application, you will request to your cloud service provider. Let's say this is your cloud service provider. You are making a request to the cloud service provider. Inside your cloud service provider, there may be a complex environment. There may be a lot of complexities are there. How these systems are connected, where is the backup, where is disaster recovery, a lot many things are there. But your provider, cloud service provider, whether it is Google or Amazon or any other provider, they will treat the entire system as a single system. That's why we call that as a single system image. Whole system is treated as a single image. Although it is not a single system, maybe there are lot many systems are working for that particular application. But in order to avoid the complexity in front of the user or in line within the view of the user, we treat that as a single system. So they can solve that particular problem. So these type of computings are also sometimes called as peer-to-peer computing. So every computer is a peer. Every computer is a peer, it is communicating with other peers. That's why we call it as a peer-to-peer computing, and it is an application, distributed computing application. For example, here you can see, if you compare these peer-to-peer computing with the client-server architecture, both are comes under the distributed computing. For example, here you can see a particular client wants some kind of resources. So client has made a request to a particular server. So that is called as invocation, or you can say request. We call that as a request response, or we call it as a invocation and reject. So if a server is having the resources which is asked by a particular client, then the server is going to return the result to the client. But if the server is not, if the resource is not available, then the client request is put on hold, or it is queued until unless the resource becomes available. Now, if another client is making a request, it may request some different kind of resources also. Whatever requested by this client, it may be different from any other client. So although this client is on hold, but if the resource is available, which is asked by this particular client, so we can provide it. So based on the requirement of the client, the server is going to provide the services. Sometimes what happens, server can also behave like a client. So whenever a client is asking a request to a server, let's say the server has seen that there is no available resources. So the server will be change its mode to client and make a request to another server. That is also possible. And this server is returning that result, okay, to this client, which is a server. Now this server is returning that result to client. So ultimately, this server is serving the request of the client. However, this client has no idea about it. Right? Suppose I am asking you something, you don't have that. You have asked your friend to provide that one. Once your friend is provided, you have given that things to me. So for me, I believe that these two systems are a single system. I don't want to know that whether it is out from here or that there. Okay, that is an example of a single system image. So here client invokes a individual servers. Here you can see a service provided by the multiple server. Here multiple servers are there. They are connected to each other. One server can be an email server, another may be a network server, another may be a storage, whatever may be. Okay, there are different kind of servers. So clients will make a request to a server based on what kind of service that particular server provides. For example, let's say this server is providing computation and this client needs computation, so it is asking to that particular server. Similarly, another client wants let's say a storage. The storage is available in this particular server, so it is asking to that server directly. So all the servers may not be providing the same type of resources. They may provide different kind of resources. So this is an example of a peer-to-peer application. So you can see this is a peer, this is another peer, another peer, this is another peer, this is another set of peers. So they have a partial role. This is a distributed application, so it is having all are having a partial roles, and they are exchanging the objects or sharing their resources to execute any kind of task. Especially for any complex scientific engineering applications, we actually use the distributed computing or peer-to-peer computing. Now coming to another computing paradigm that is called as grid computing. So many researchers also suggested that the grid computing is the backbone of cloud computing. But prior to grid computing, we have another paradigm that is called as cluster computing. So in grid computing, the systems are heterogeneous. So if you take a group of systems, their configurations are different. Every system is not equally capable or not having equal storage, equal bandwidth, equal computation, and so on. But in the case of cluster computing, cluster is taking homogeneous nodes. So all the nodes are more or less having the same type of systems. Like in a computer lab, generally we purchase 30 and 50 computer systems at the same time. So definitely all the systems are having more or less the same configurations. So grid is merging different heterogeneous computing systems, but cluster is merging different type of homogeneous systems. So many people have defined grid computing in different way. So if you go for IBM mentioned that it enables the virtualization of distributed computing and data resources such as processing, network bandwidth, storage to create a single system image. The main properties of distributed system is sharing of resources and making the whole system as a single system image. It is granting users, applications, seamless access to various IT capabilities, and just as an internet user views as a unified instance of content via web. Whenever we are using anything like Gmail also, we have a web browser. Through web browser, we are typing Gmail and we have internet connectivity, we are accessing it. Right? So every service is provided through a web browser. In cloud also, if you go for Amazon or Google, any service you want, you are making a request by creating a respective account and you are accessing that account through a web browser. So grid is meant for voluntary purpose, or grid is also coined in 1990 for various scientific engineering applications to solve the problem. Grid is never commercialized. Like cloud is fully commercialized. Grid has never meant for it is a commercialized platform. Now, people always see the comparison between our electric power grid, the computing grid. Before grid computing, we have electrical power grid. So, if you visit to any dam or any places, there you can see there is a grid. Near to the water sources, we have a grid. So the grid is actually generating the electricity. Then the electricity is transferred from one location to another location. So as a user, for example, in our home, we have sockets, right? We have wall sockets. Suppose I want to charge my laptop or I want to charge my mobile. So what I'll do, I'll simply connect it with a charger, right? I'll connect with a socket to with my computer system, right? And I'm not worried about where electricity is coming, where is the transformer, where it is generated. I don't want to know also, right? Because simply I am paying in each and every month based upon my usage. That's why there is no care or no consideration where or how the electricity is generated. In the similar kind of concept, we want computing resources, or we say that is a virtual machine through virtualization technology, without knowing that where it is created and who is maintaining that, who is doing the maintenance, who is doing the testing. These things we need not worry about it. So grid term, we focus on the computing resources. Electric grid, we look into the electricity, but grid case, we look into the computing resources without knowledge of where the location of the resources and underlying technology or hardware or software or operating systems. Now, when to use grid computing? Again, I told you distributed, it is also part of distributed computing. If your nature of application supports, then only you can go for grid computing. So if you need massive computation, definitely you can go for grid computing. When multiple organizations collaborate each other, they can also create a grid to exchange the resources, or they can execute different kind of applications. So in that case, when a single organization is incapable to execute a particular application, the organization is requesting another organization to create a virtual organization so that resources can be provided combinedly. Right? In that case, we need grid computing. Now, if you go for scientific research application, as I already said, like if you go for computer simulation modeling, it is not possible to enhance the software system or hardware system of a organizations for a particular project. So in that case, we are only using grid computing. Like this SCTI at home or NFS at home, Milkway at home. These all projects are running under our grid computing, right? So if you want a data visualization, for example, if I go for a biology domain data, space data, okay, or astronomy data, right? Or gravitational physics data. So in that you require large computation. So grid computing is the solution for it. You can see some of the particular applications like crystallography or detection and modeling of natural disaster, material characterization, reactor application, physics applications, weather forecasting. Irrespective of the application, where there is a large demand of computation, storage, network, or any other resources, the only solution is to go for grid computing. Now, if you look into grid, like I mentioned, the distributed computing, we are executing two different type of tasks. One is computational task, another is data intensive task, compute intensive task or data intensive task. So grid is also categorized into various types. One is called as computational grid, another is called as data grid, collaboration grid, network grid, and utility grid. Okay. So more or less, you can say computational grid related to our computation, data related to if you want to process the large amount of data or store large amount of data. Collaboration grid is combining multiple organizations into a single organization. For example, suppose let us take three organizations A and B and C. So individually, these organizations are having, let's say, 20 servers, 15 servers, and 10 servers. So in order to run a particular application, let's say X application, suppose you need 30 number of servers. So A cannot fulfill your requirement, B cannot fulfill your requirement, or C cannot fulfill your requirement. But what they can do, A and B, they can collaborate each other through a collaboration grid so that they can provide resources to this application X. Okay. Or if you need another application Y in which you require, let's say, 40 number of servers. So A, B, C can again be combined because together they have, I think, 45 number of servers. So they can provide the resources. So in that case, we are going for collaboration. Okay, where we look into different things like we also focus on fault tolerance aspect. We also look into robustness aspect, scalability aspect. In that case, we go for the collaboration grid. Similarly, we have network grid and utility grid. These are other forms of the grid. Yeah, anybody is having any question?
Yeah, is my voice audible?
Yeah. Please continue.
Yeah, so my question was like X needs 30 server for running this application.
Yeah,
So what if like okay, it would take 20 from A, but
yeah,
then from B, like you told in the previous slide, that client server communication, that server is not available
yeah.
in case. So can they like form these, like A, B, C can collaborate in that case?
Yes, they can collaborate based on the type of application and requirement. One organization may collaborate with another organization. For example, here you can see as A plus B, it is 35. So if they combine or they collaborate each other, they can provide resources to X application. But BC, if you combine, it is only 25. But our requirement is 30. So they cannot combinedly provide the services to the application X. But at the same time, ABC can also combine so that you can say I'll take, let's say, 40 servers. Then A can give 20 server, B can give another 10 server, C can give 10 servers. So we can run the application Y. So based on the need, scientific application or engineering application need, one organization is associated with another organization.
So in case if the servers of B, 15 servers of B are not available, then A, B, C,
Yeah,
three
definitely,
of them will collaborate and
definitely,
provide 32 X.
definitely, definitely.
Okay,
So
thank you.
they actually, because I'm saying collaboration perspective by thinking that their servers are free, but what you pointed, that is correct, because many organizations, they are executing their job also. Like out of 20, maybe 5 servers are busy in their work. Out of 15, let's say 3 servers are busy. Out of 10, 2 servers are busy. So excluding that server only, they can share. So if it is not fulfilling the criteria of a particular application, then obviously you need collaboration with other organization. Okay, so these are some of the components. We can go for, as I said, it is a heterogeneous one, right? We have heterogeneous resources, but in the cluster case, we will go for homogeneous resources. So in order to form grid, there are 3 important components we have. There are many communities, like many communities means many organizations. They are ready to donate the resources. Like if you can say, I'm saying BYNC, if you install in your institute computer systems in all your systems. So whenever your systems are you are not using system or they are completely free, so BYNC platform will execute a particular application in your computer system. And they are completely government funded projects. So we should not think about whether there is a security leakage or some kind of issues or bugs or it is impacting our computer system. It will not be the case. So these are the some components. Now coming to another computing paradigm, that is called as cluster computing. The only difference, as I mentioned, that is getting homogeneous computer system. But when you need a large number of computer system, getting the computer system of the same configuration is not practically possible. Like if I ask, I need 100 computer systems, all 100 computer systems are having same configurations. So you may not get 100 system in a particular organization. So what you can do, for example, 30 systems are having same configuration. You can make a cluster. I can say this is a cluster 1, having 30 computer system of the same configurations. Another cluster I have created in which 50 computer systems are having same configuration. Let's say I am creating another cluster C3 is having, let's say, 20 number of computer systems. So I can connect these 3. So we call that is a heterogeneous cluster. But clusters are initially homogeneous only. They are not heterogeneous, but later point of time, in order to increase the number of systems, so there is a concept called heterogeneous systems. So some of the components of this cluster is personal computer systems, workstations, or symmetric multiprocessors, that is SMP, can also be part of our cluster. SMP is having parallel processing, multiple processors, same multiple processor. Okay, symmetric multiprocessors. So they can also be a part of a cluster system. And there is a popular protocol that is called as MiriNet, which is a lightweight protocol that is used in the case of cluster computing. And network is fast in the case of cluster because more or less these clusters are formed inside a particular organization. Or you can say the latency is also very low. You will get delay. Latency means delay. Delay between a single cluster is very low because they are in the same cluster. There is no security issues. But if you go for heterogeneous clusters, definitely latency is quite more in comparison to the homogeneous cluster. But more or less, the cluster, it is a part of a distributed system only, and systems are, if it is a heterogeneous cluster, it is completely loosely coupled. And inside an organization, these clusters are generally formed based on, let's say, different kind of hierarchy. For example, entry-level people, they can be put in a particular cluster. Medium level people, employees, they can put in another cluster. High level management people can also use another type of cluster. Now, cluster is also several type, like grid also we have seen utility grid, network grid, computational grid, data grid. Cluster case also it is having three types. One is called as high availability and failover cluster. So if a particular node is failed, another node is going to replace that particular node. Similarly, we have another type of cluster that is called as load balancing cluster, which ensures that the load is equally distributed among all the systems. And we have another cluster that is called as parallel and distributed processing clusters. So based on the typical type of applications, people have formed different type of cluster, but more or less the same technology is used behind these clusters. So some of the components of the cluster you can see here, cluster nodes are there. So you can see there are several nodes. I can say these n nodes are having one cluster. These n nodes is having another cluster, right? And they are connected through high speed switches so that we can provide the service without any hindrance. So network is one of the part. Which switch is connected to which cluster, that also you need to know. That is network topology. Everything is more important in order to access the components of the cluster. Some of the benefits of cluster is that system availability is more. Okay, if you have a large number of systems, so even if some system is failed, so the network is active. So availability is quite more. So generally availability is calculated as 1 minus downtime. I can write dt is downtime divided by uptime. For example, you can see, suppose you are observing internet for 24 hours. And out of 24 hours, you found that 30 minutes, the internet is not available. Okay, so downtime is your 30 minutes. Uptime is 23 hours, 30 minutes. Okay, out of 24 hours, we observe the 30 minutes it is down. Or if you talk about the cloud computing service also, you can say the service is not available for 30 minutes of time. But rest point of time, it is available. So that is called as your uptime. So if you subtract 1 minus that uptime, downtime by uptime, we call that is a availability. So obviously, high availability is required. If availability is 99.9%, definitely it is better. But people are developing many methods to improve or adding another 9 to the system. So getting 99.99% is much more better than 99.9%. We cannot take 99.9% as 100%. So many cloud service providers are also day by day, they want to add extra 9 in the in their availability. We have redundant, RAID is redundant area of inexpensive disk or independent disk for copying our data or storing the data in such a manner that if any failure happen, so it is not going to impact. So that is called as hardware fault tolerance. In that case, also cluster is more beneficial. Scalability wise, also it is more beneficial. Reliability Obviously, if you go for multiple component and one component is supporting any other another component, definitely reliability is increasing. Redundancy always increases the reliability. If you use more component instead of one system, if I use 5 systems, then definitely my fault tolerance capacity is more, reliability is more, and at the same time, you are adding so many resources to the system, so scalability is also more. And cluster or grid, they primarily focus on the high performance computing, but cloud preliminarily focus on the high throughput computing. High throughput case also you want to achieve HPC, but we are goal oriented activity rather than processing the same set of application in a high level cluster or a grid. Now the last computing paradigm before introducing cloud, that is called as utility computing. So already I mentioned there are 5 utilities we discussed in this lecture. We started with water is one of the utility. We have seen electricity is one of the utility. Okay. Similarly, we have seen telephone is another utility. Gas connection is also one of the utility. After 4 utility, we want the 5th utility system in our environment, that is our cloud. So utility computing, as the name suggests, utility indicates that based on your usage. If you use more, then you have to pay more. If you are not using, you are not going to pay. Right? For example, if you are out of station for 1 month, then your electricity bill you are getting as a base charge. Let's say base charge is 100 rupees. So you are getting the base amount. Okay, if let's say in the base amount they are giving some 50 units, something like that. So if you are using up to 50 units also, you are going to pay the base amount. After that, if you exceed the quota, you are going to pay based on your usage. So rather than charging a customer a flat rate, like I'll say you use as much as possible, you have to pay, let's say 10,000 rupees, which is not economical for everyone, right? So rather than charging in a flat rate, so you want to provide the services and we charge the customer based on their usage. But utility computing also says that also there is no need to invest anything in the infrastructure, which is also adopted by cloud. Initially purchasing the infrastructure, maintaining the infrastructure, configuring the infrastructure, it is very tedious job, right? But if you go for utility computing, almost the cost is nil, right? There is no upfront commitment. So with a low cost, you can get your resources and you can use the resources. So you have to pay as per your usage. We call that as a pay per usage model. So this is an example of utility computing. You can see this is an example that these are IT resources. It is maybe a computation, maybe storage, or maybe bandwidth, or many resources. So it is providing just like a water or a you can say gas or whatever maybe. So it is providing the resources to the customer based on their requirement. And there is a meter which takes care of how much resources you are using or what duration. Based on that, they are going to charge you. Like I told you, to install AWS, to create one account in AWS, I'll tell you the softwares what are required to communicate with AWS later. So if you have created AWS account, so you know that you need to provide your debit card and credit card information. Once you provide the debit card and credit card information, to check that whether your debit card and credit card information is correct, they are charging a nominal account. So somebody also mentioned that the amount is 2 rupees, right? Sometimes they charge 1 rupee, 2 rupees, something like that. The way suppose I am registering with a UPI, there also they are charging some amount, minimal amount, to check that our account is correct or not, right? And once you activate your AWS account by paying by providing this payment information, you will get 750 hours per 750 hours of computation per month. Okay, 750 hours is very huge, right? So if I ask you how many hours are there in a per month, you will get maximum of 750 hours per month. But if I ask you calculate how many hours are there in per month, what is the answer? Can anybody calculate how many hours are there in a month? By considering, let's say, 30 days. So 30 into 24, right? So it is 720, right? So somebody can ask why they are giving 750 if 720 is there. Why they are giving 750? Because if you buy a computational resources or a virtual machines and you make it active for whole month, also you are not going to pay. But at the same time, you can launch multiple virtual machine also. Suppose you need a virtual machine for doing your research work. You need a virtual machine for a collaborative work. So in that case, if you are using two virtual machines for 2 hours, so it is considered as a 4 hours. So at max you can go for 750 hours. So once you exceed the 750 hours of computations, they will directly charge from your debit card or credit card account. So you have to ensure that you are not exceeding the free quota. Similarly, they are also providing some GB of storage free of cost that you can store in Amazon for 1 year. So there is no charge. But if you exceed that quota, again, they will charge some nominal amount, or based on your usage, they are going to charge it. So these are some of the things which we have seen, that is pay for usage. We can do provisioning the resources data center by providing virtualization technique. Through virtualization technique, we can create the virtual machine on top of the physical machines, and we can solve the resource utilization problem, because earlier one computer system is only used by a single user, right? If the user is not using, then the system is idle. But if I take the resources of this machine, which I call as a physical machine, and through virtualization, if I create two virtual machines, let's say virtual machine 1 and virtual machine 2, and one user can use virtual machine 1, and another user can use virtual machine 2. So instead of a single user, if two user is using these computing resources, definitely the resource utilization problem can be solved, or resource utilization is going to be improved. Similarly, other points you can go through. Now you can see consumer perspective and provider perspective. If you look into consumer perspective, consumer is not willing to purchase any infrastructure, right? But consumer is ready to purchase the service. Okay, I don't want a power station, right? I want electricity. I don't want to go for a gas plant. Okay, rather than I want a gas connection. So customer is asking service procurement, and provider is having the infrastructure. If you go for Amazon or you can go for Google, they are having infrastructure. So they can provide infrastructure to the consumer. Okay. So consumer side, it is service procurement. Service procurement is given by the provider through its infrastructure. Similarly, customer wants service assurance. Customer will definitely say that at any point of time, you should not disrupt my service or intrude my service, right? Downtime should be low. So customer will ask for the service assurance. Provider is going to provide the service assurance. Customer will also ask about availability, reliability, robustness, all these parameters customer will ask. And formally, there is an agreement between the consumer and provider, which we call as a service level agreement. So SLA is a formal agreement between the consumer and provider. So whatever terms condition the consumer wants to put, or provider wants to put, so they need to agree upon a particular document before any service is provided to the consumer. So they meet in a common platform to exchange the resources and charge some amount based on their agreement. So there are different kind of pricing schemes are there. Like if you go for mobile companies also, whatever provider you are using nowadays, I think we are paying 719 rupees or something like that for 84 days, right? So they are saying us to use unlimited service, unlimited phone calls, and let's say 2 GB per day or 1.5 GB per day, and we have to pay 719. So it is a flat rate, right? It is a constant rate without looking into how many minutes you are talking to your friends. So doesn't matter, but you have given 719 means you can use for 84 days. But many users are using tiered concept. The pricing scheme is tiered. Tiered means I can say 0 to 100 units. Let's say you have to pay 1 rupees. 101 to 200 you have to pay 2 rupees. Just like our electric system. 201 to let's say 300 you have to pay 3 rupees, and so on. So if you have crossed a particular tier, the charge is more. Many people are going for the subscription based. They are asking, I am using the service for 1 day. Whatever amount you want to take, you take it. But 1 day I can do unlimited internet, unlimited, let's say, phone calls. So there are different type of schemes are there, like meter schemes. Based on the meter, you can charge constant rate. Let's say it is 200. Then without tier, you have to say that per unit, let's say 5 rupees. Okay, so there are different pricing schemes are there. So it is written in the service level agreement what pricing scheme a user has agreed to give to the provider. So before getting any kind of services, we need to clear about these charging models. And in AWS also, you can go to the billing dashboard. You can see your name in the right corner, and there is a billing dashboard. You go to billing dashboard and periodically check that what is the amount they are charging, because all the services that are available in AWS is not free of cost, and we should not use the services which are not free of cost. Okay, otherwise they can directly charge from your credit card or debit card account. Now, so there are some risks are also always there, right? If the data is stored remotely in some place or not in your local drive, then always there is a question about security. Always there is a question about backup. But these plans are in such a manner maintained by the cloud service provider, so you need not worry about it. Because these are everything is maintained in the service level agreement. If there is a data lost, what charge, what penalty is imposed to the provider, everything is managed. So these are some of the risks associated with other paradigm, but cloud has well taken these risks so that nobody should worried about these things in nowadays. Okay, coming to the last part of this talk, I'm talking now about the main technology, that is cloud computing. So whatever we have seen with respect to distributed computing, parallel computing, client server architecture, peer-to-peer computing, utility computing, cluster and grid computing, the more or less same concept you can find in the cloud computing. So there is an organization that is called as NIST, that is National Institute of Standard and Technology, US. So generally NIST releases some definitions and classification of that particular technology based on different characteristics about any new technology. So NIST mentioned cloud computing is a model for enabling ubiquitous. Ubiquitous means anywhere. You can access to cloud services anywhere in the world. Anywhere, any location is fine. You can use, but only you have internet connection to access your resources. So it is convenient on-demand network access to a shared pool of configuring computing resources. For example, if we talk about swimming pool, in swimming pool you have a plenty of water, right? If I take a cup of water from a swimming pool, okay, so you can see the water level is not drastically increased or drastically decreased, right? Similarly, in cloud case, we have a large pool of resources. Like swimming pool, we have water. In data center, we have a large pool of resources, variety of resources. It may be network, it may be server, storage, application services, and so many things. So based upon the user's need or user request, okay, through the service level agreement, we are going to release these resources from this particular pool. And the pool is such a large pool, we never say that it is going to be exhausted, right? Like you can see, suppose somebody require at max, let's say 1 lakh rupees. So if I say one person is having 1 crore, right? So 1 lakh in comparison to 1 crore, it is very nominal amount, right? So in that case, you can say it will never reach to that particular limit. So every cloud service provider has a plenty of resources, and they are more sure that at any point of time you cannot cross that particular limit. And based on your requirement, they are going to release the resources. And once your requirement is fulfilled, you don't want to continue that particular resource, you have to release that particular resource so that that can be again added into the pool of resources. So this is cloud global cloud marketplace, where you can see in the left side we have various customers, and the right side we have providers. So customers are asking so many questions to the provider. Like this customer says that I need to grow my infrastructure, but I don't know how long. Let's say this person has started a startup company. Nowadays, ministry is also encouraging people to go for startup companies. So when you start your company, you are not sure that whether you can compete in the market or not. What is the market scenario? You may not be aware of that, right? So definitely it is in your mind that if I spend towards infrastructure, purchasing various computer systems, whether or servers, whether my model is sustainable or not. So at the same time, a provider says that I have a lot of infrastructure, that I want to give in rent. You don't need to purchase infrastructure for your thing, but I can provide in rent. That may be one of the solutions. Similarly, another person says that I cannot invest in infrastructure. I just started my business. Initial days, it is very difficult to spend in infrastructure. You don't have enough budget. So obviously, we can provide it. Similarly, a provider says that I have surplus infrastructure. After maintaining my own infrastructure, own organization's requirement, I have surplus infrastructure. I want to make it use of any other customers. So these customers and providers, they are meeting in a single point that is called as global cloud marketplace. Okay, they can exchange the resources. Okay, and they have to sign in a service level agreement. Now coming to different types of cloud. So based on different characteristics, cloud is categorized into different types. For example, if you see in the deployment perspective, deployment means where the cloud is located. It is located in your geographical boundary, or it is located in your organization or outside organization. So you can say it is 4 types. One is called as public cloud. Public cloud is for public usage. Like anybody can create a email service in Google, right? That is meant for public usage. So any service you want to provide to anyone, any one person can create, that will be hosted in the public cloud. There is another cloud, that is private cloud. For example, NIT Warangal has set up a particular cloud which is explicitly used for the faculty members, students, staffs, stakeholder of the organization. So if anybody who is outside our NITW organization, they cannot use this particular cloud. Whatever service we can provide, anybody can use, right? If it is a public service. But we have set up our cloud, which can be only but restricted to our organization boundary. So in that case, we can go for private cloud. So private cloud can be categorized into 2 parts. It may be off premises, it may be on premises. So if you are maintaining your own cloud and you are hosting your own cloud, we call that as on premises. It is within your campus. But off premises means somebody else is maintaining your cloud. Like most of the organizations, they are using email service, but that email service is similar to our Gmail. So in that case, we are going for off-premises cloud. Google is maintaining for a particular organization. So that is called as off-premises private cloud. And sometimes we need collaboration between multiple organizations. Like if you talk about multinational companies, let's say TCS, Infosys, Microsoft, and other companies, they have several branches in various locations. Like they have a branch in Delhi, another branch at Mumbai, another branch at Kolkata, another maybe at Hyderabad. So in order to execute any kind of project, they need collaboration of all these locations. Okay. The people who are residing in different locations. So in that case, we can go for the community cloud. Or ministry wants, let's say central government wants to launch some kind of projects in association with state governments. So in that case also they can go for a community cloud. Similarly, we have hybrid cloud by combining public with private or private with community, right? So like a private cloud, community cloud is also maybe off premises or it may be on premises. But if you look into the service perspective, cloud is categorized into infrastructure as a service, platform as a service, software as a service, and later point of time, people have come up with various types of service. Like those people who work in IoT, they come up with sensor as a service. Those people who work in healthcare, they come up with healthcare as a service. So we call that as everything or anything is a service, that is called as XaaS. So infrastructure is particularly focusing on the computation and storage. More or less, it is related to the hardware. And these hardwares are provided by creating the virtual machines. And platform is focusing on runtime environment, or you can say middleware. And software as a service focuses on various kind of applications or APIs. So these are the 4 deployment models and 3 different services. Apart from that, we have 5 different service attributes. So what are the service attributes? So as for NIST, many people have defined the service attributes in a different way. But NIST mentioned there are 5 different type of service attribute. One is called as resource pooling. Like I told you, there is a pool of resource, and whatever customer is asking, it is just a cup of water in a swimming pool. Okay, that is very small. So cloud maintains a resource pool to provide resources to the customer. There is another characteristic that is called as broad network access. Through any device, you can connect to cloud, whether it is a personal digital assistant or your mobile phone or laptop or desktop, any device which is capable to connect to internet, through which you can access to the cloud services. That's why it is called as broad network access. Another one is called as measured service. I told you there are several ways you can charge to your customer. So you have to measure the service. Somebody is measuring with respect to meter. Somebody is, let's say, measuring with respect to how many hours you are using, or how many seconds you are using, how many days you are using. Based on that, you can charge some amount to your customer. That's why it is called as measured services. Next is on-demand self-service. So at any point of time, if you need, whether it is night 2 or day 2, or it may be early morning or early late evening, so you can use the cloud service. That's called as on-demand self-service. You have to create your account and you have to use it. That's why it is a self-service. There is another concept that is called as rapid elasticity. So you can increase the number of resources or you can decrease the number of resources as per your requirement. Like today you need 10 servers, tomorrow you need, let's say, 1,000 servers. Day after tomorrow you need 10 servers. That also you can do through this characteristics, that is rapid elasticity. The next is, there are many success stories behind cloud. Like I'm showing you, there is 3 success stories, but in practical there are so many success stories in the cloud. Like if you see the newspaper, which is very popular in New York, that is called as New York Times. Like we have Indian Times or Times of India, they have New York Times. So New York Times wants to go for a e-friendly, you can say, or you can say they want to create a portal in which all the newspapers need to be archived, so that anybody needs a newspaper of any particular day, they can do it. So what they did, they subscribed to Amazon. Amazon provides 2 popular service. One is EC2. EC2 stands for Elastic Compute Cloud. S3 is Simple Storage Service. So they requested Amazon to provide these 2 services, and within 36 hours, they are ready with the portal. They are able to provide this, you can say, electronic format of newspaper to the customers. Nowadays, all the newspapers you are getting in e-paper format, right? Early days it was not there, but Amazon is able to do it for New York Times. Similarly, we have Animoto, is a very popular company for making videos. Like if you talk about a marriage ceremony or any functions, we generally click various photos. Later point of time, we convert these photos into various videos, right? So Animoto hired Amazon Web Services, and initially they are new to the market, so they started with only 70 servers because they are not sure their market growth. But suddenly they have seen that many people are interested in their product, so they increased the number of servers from 70 to 8,500. So imagine this much capacity they have increased in Amazon. But purchasing 70 servers to the 8,500 servers is practically impossible. I cannot increase my infrastructure up to this much big number if I maintain my fixed infrastructure. So that is also one of the real life example. Another popular company that is called as Little Floppy Toys. It is just like a startup company. So this Little Floppy Toys, if you use this application, they will tell you which one is the nearest bicycle rental shop. Elders, if you remember, like if you want to visit a new city and you want to hire a scooty or you want to hire a bicycle, so you have to go to nearest location and you have to submit your card, Aadhaar card or some card, some ID proof, and you have to also give some money, and they will give a bicycle or a scooty for 1 day or 2 day based on your agreement. The similar kind of things is done by Little Puppeters. It is able to tell customers that here is the bicycle rental service. So they have taken Google App Engine as a service, and they are in the market within 1 week. So you can see what is the advantages, that they don't own any kind of servers. They don't want any kind of complexity of the environment. Everything they have given to Google. Google is maintaining everything for them. So that is also one of the real life applications of cloud. Okay, we'll stop here. If you have any questions, you can ask. I'll cover rest of the things in my next